And otherwise, meeting you after a long time. If you're busy with your exams. So today we are going to learn about an interesting triangle, which we call it as the petal triangle. It's a triangle created by the fruit of the perpendiculars, meaning if I draw altitudes for each of my sides. So altitude, trying to draw a smaller triangle though. For an acute angle triangle, so it'll be easy for us to understand. Perpendicular, I'm trying to draw perpendicular for each of the sides. Okay, let me name the points also. Answer the perpendicular AD, BE, and CF. Let me mark the angle also. Yes, see. I'm going to mark the angles, people. So 90 degree, 90 degree, 90, 90, 90, and 90. Now, this point is called as intersection point of altitudes. It's called as orthocentre. It's called as orthocenter, generally marked by the letter H. Now you can notice this quadrilateral FHDB is having opposite angles as 90 and 90. Okay, they are adding up to 180, meaning there will be a circle passing through that quadrilateral because cyclic quadrilateral has the property of circle passing through it. So there is a circle passing through this quadrilateral. If you start marking the angle, let this angle be theta. This is angle 90 degrees. Okay. So this angle be 90 minus theta. This angle be 90 minus theta. And then further, this is, I'm going to draw line segment joining D to F as well. So why you could ask me? Because I want to use this angles in the same segment property. So this theta angle is created by this FH chord. So the same angle be created here also. That means the leftover angle be 90 minus theta. Okay. Created by this chord, angles in the same segment. BF chord is creating at this point H 90 minus theta. Here also it is 90 minus theta. Okay. Are you clear? So now what I'm going to do next, I notice there is a 90 degree at E point, also at D point. So that means there's another circle passing through this quadrilateral as well. H, C, and then so you can see H, E, C, D is again another circle. We have another circle passing through them. So again, I'm going to use the same similar properties, people. So this angle is 90 minus theta is created between the lines BE and CF, isn't it? So then this angle will also be vertically opposite to it, will also be 90 minus theta. That means this angle will also be theta because of angle sum property. 90 minus theta, 90. So this should be theta. Okay. So I'm going to bring in one more line so that I can use some angles in the same segment property. So I'm going to join D to E. So now you can notice HE as a chord is creating an angle theta here. This means the same HE as a chord should create an angle here. That should also be theta, isn't it? So from that we can understand this line DH is acting as angle bisector in this triangle DFE. So this DFE triangle is only called as your pedal triangle. So that property only we are slowly revealing what is happening to it. Okay. So now a few more things we'll try to mark slowly. So now there's 90 degree, 90 minus theta, everything we are slowly marking. So this is a straight line. Okay. So you can mark the angles. I would further ask you to look at this angle at F, which is 90, angle at E, it is 90. So meaning there's one more circle passing through A, E and H also. Hope you understood. So there are three circles here because each of them is a cyclic quadrilateral. AFHE, FHDB, EHBC, they are all cyclic quadrilateral. Okay. So now further angle markings we require. So let me go with this angle being alpha. Okay, if that angle is alpha, that's being created by the FH chord. So I need one more line to show angles in the same segment property. Okay. So the FH chord creating angle at A as alpha, that will also create angle at E as alpha because that will show angles in the same segment property. And similarly, alpha 90 degrees. So this angle will become 90 minus alpha. This angle will become 90 minus alpha. So again, you can understand this 90 minus alpha angle is created by this CF line and AD line. So here also this angle also be 90 minus alpha. Vertically opposite angle, you can see that. So 90 minus alpha, 90 degrees. So this angle be alpha. Okay. So then this angle be, you can just see this is a straight line. So this angle become just theta plus alpha by linear property. That sum of angle should be 180 on a straight line, right? So because of that. Understood? Huh? So now we're just considering the other portions. So this angle, because this is totally 90, so this angle be 90 minus alpha. So this is again created by which chord? It's created by the AF chord. So it's creating 90 minus alpha here as well. That also you can see. So slowly we are just chasing our angles. We are trying to fill them upon. So 90 minus alpha, 90 minus alpha, theta plus alpha. So this angle also be theta plus alpha. So this angle, as you can notice, so this angle belongs to which circle? It is belonging to the second circle which I have drawn, and it's created by this chord, which is HD chord. HD chord is creating an angle alpha here. So that means this will also create an angle here alpha. From that, what we have understood? That means we have understood this line is also acting as the line starting from E to H is also acting as an angle bisector. So we have learned in triangles, the intersection point of any two angle bisector is called as incentre. So from this we understood the H, which is the orthocentre of H, which is the orthocentre of triangle ABC, has become the incentre of triangle DEF, which is your pedal triangle. What is pedal triangle? It is nothing but the triangle formed by the foot of perpendiculars of any triangle, of our original triangle. Understood, people? Hope you like this concept. So I'll meet you in a interesting concept in the next session. Thank you.